Hello and welcome to another past paper session. Today's paper is October-November 2023. I'm solving a paper 3, variant 2. Let's start solving. The first says sketch the graph of y equals to 4x minus 2. So I'm going to draw an axis and call that my origin. Different. 2, 4, 1, 2, 4. Okay, marking my axis quickly. 2, 3, 4, 5, 1, 2, 3. Okay, I hope I can see the marks now. Switch off the ruler and say that I have 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, and 1, 2, 3. Okay, how I draw these graphs is I say that when a modulus opens up, it opens up with a plus and with a minus. So you have two different equations to draw and then you look for a v. Okay, so 4x minus 2 and minus 4x plus 2. Okay, so drawing the first line, I see that the y-intercept is minus 2 and the x-intercept should be 0 equals to 4x minus 2. That gives me x equals to half. Okay, so the first line that I'm drawing with the blue color is minus 2 and half. So the line is going to go something like this. Okay, then the other line has a y-intercept of, let's draw that with a green, y-intercept of 2 and x-intercept of half, I think, if you calculate that. Okay, so you have half and 2. You erase the part that is below the V and you have your sketch. Okay, this should be with one color. I've drawn it with two colors just to show you different lines, and that should be it. Okay, then on to the next question. It says solve the inequality 1 plus 3x is less than 4x minus 2. I could solve this using the graph. I could draw it on the graph and sort of come up with an answer. I could also do it without the graph as well and say that I will square both sides. 1 plus 3x squared is less than 4x minus 2 squared. I could also do a plus and a minus. That's absolutely your call. 1 plus 6x plus 9x squared is less than 16x squared minus 8 into 2 is also 16x plus 4. Moving everything to one side gives me 7x squared minus 10x minus 22x plus 3. Okay. I will solve this on my calculator, get you two solutions out of this. 7 minus 22 and 3. So I get x equals to 3 and x equals to 1 over 7. Okay, on the exam you should show me the quadratic formula as well. Now since this is an inequality, I'm going to say that my solution lies here or in this region. So x is less than 1 over 7 or x is greater than 1 over 3. Now remember that when you have modulus on one side and an expression on the other side, what you need to do is you need to verify your answers as well. Actually, this is not something that I should have done. What I should have done is I should have drawn areas 1 over 7, 3, and then taken numbers in these regions. So let's take a number greater than 3, that's 4, between 1 and over 7 and 3, that's 2, and then I can take 0. I'll verify each of these three numbers. If these balance the inequality, they are answers, otherwise they're not. So this gives me 1 is less than 2. Yes, that is the correct region. So 0 is the correct region. 1 plus 3 times 2 is less than 4 times 2 minus 2. So is 7 less than 6? No, that's not true. So that region gets cancelled out. Then the third region is 1 plus 3 times 4. 4 times 4 minus 2. So I get 13 is less than 14. Yes, that is also a correct region. So my answer should be x is less than 1 over 7 or x is greater than 3. Okay, so both are correct answers and I will give you that as the final answer. Remember that you have to do this whenever you have an inequality on one side and a number on the other and an expression on the other. Moving on to question number two. Question number two says the parametric equations of a curve are x equals to ln t square, e and 2 minus t square. Find the gradient of the curve where t equals to e, simplifying your answer. So first you do differential of x. So you get dx over dt 2 times ln t power 1 into 1 over t. And dy over dt is basically e power 2 minus t square into 0 minus 2t, the differential of the power basically. So dy over dx is dy over dt divided by dx over dt. That gives me e power 2 minus t square into minus 2t divided by 2 ln t over t. Then I can say that this is e power 2 minus t square into minus 2t. Write that simply. Multiplied by t over 2 ln t. I want t equals to e, so I'm going to write minus 2e, e power 2 minus e square into e over 2 ln e. Let me check if I'm going about this correct. Looks correct so far. Yeah. Okay. So let's see what we get. So 2 and 2 cancel out. Minus e square e power 2 minus e square over ln e is 1. So I get the powers added for e. It's going to become 2 plus 2 minus e square. That's minus e 4 minus e square. Okay, so continuing with question number 3, it says 2x cubed plus ax square minus 11x plus b. So it is given that b of x is divisible by 2x minus 1. So I will plug in x equals to half to get y equals to 0. That's what being divisible means. And that when x is divided by x plus 1, so x equals to minus 1 and y should equal 12. So I'll first plug in half and try to solve this. That gives me 2 over 8. So a over 4 plus b equals to 11 over 2 minus 2 over 8. That's a plus 4b equals to 21 over 4. Yep. Yeah, 21 over 4. Then 2 times minus 1 cubed plus 8 times minus 1 squared minus 11 times minus 1 plus b equals to 12. Okay, that's another equation that I have. So I get minus 2 plus a plus 11 plus b equals to 12. A plus b equals to 3. Changing the signs, I think this 4 is also going to vanish. B equals to 6, and so that's A and that's B, and those are the correct answers. Okay, moving on. We have question number 4. Question number 4 says, on a sketch of an organ diagram, shade the region whose points represent the complex number z satisfying this. So this is a circle. The first one is a circle, center 4 plus 3i, and radius 2. And REZ is basically the real value of z. So the real values are plotted along the x-axis. So I'm going to say that this is the line x equals to 3. I'm going to draw this for you, and you can see I'm going to first draw a horizontal line. Let's take a smaller axis. Let's write 1, four. Okay, so 1, 2. I think I'll have to take a smaller axis and say that this is 1, 2, 3, and 4, 5, 6. Oops, that vanished. Let's keep that, and let's imagine coordinates in the middle. So I'm going to say that I need a circle at 4 plus 3i, so that would be 1, 2, 3 in the middle, and then 4. About here, that's the center of the circle. I know that the radius has to be 2, so I'm going to go 2 up and 2 to the left. It's tough drawing it on without having a proper grid and so on. So I'm just going to be as accurate as possible. Let's keep that here. I am going to draw a vertical line here to just say this. Okay, then real value z. So this is the real axis. The x-axis is the real axis. I don't know why this is doing that. Let's keep that. So the real value z is this vertical line that I have here. So I'm going to say that this stretches like that. And what I want is all the real values to be less than or equals to 3. So I'm talking about the region. So I'm talking about the region that is less than or equals to 3. So I'm talking about this region then. Okay, inside the circle and less than or equals to 3. Find the greatest value of argument of z for points in this region. The greatest value of argument of z for points in this region. Let's draw that with a dashed line. Remember that it's always the tangent. The greatest value of z is always the tangent. I should check my answer first in case I've done it. Mm, yeah, that is the correct shading and everything. I should mention the real axis here. That's what I have not done. Imaginary axis. Okay. Okay, then the greatest value of argument of z is from this dotted line. It always creates a tangent, and I'm going to say that when I join it with the radius, it creates a 90-degree. So what I'm going to do is I'm going to try to find this angle called x and this angle called theta and try to add the two. Now for theta, it's simply the argument of the center of the circle. So argument of center of the circle would be tan theta equals to 3 over 4 b over a. So theta is equals to tan inverse of 3 over 4. Tan inverse of 3 over 4. That's 36.87. Let's keep that in degrees for now. You could also keep that in radians. Then to calculate x, remember that the radius of your circle is 2, and you can find this length, the one stretching from the center to the center of the circle. I can say that this is the modulus of the center. So it's going to be 4 square plus 3 square. That gives me 5. So I'm going to say that sine in x is basically sine x equals to 3 over 5. So x equals to sine inverse of 3 over 5. Yeah, 3 over 5, 2 over 5. That's the mistake that I made. 23.58. So greatest argument will be 36.87 plus 23.58. 60.5. Let's check if that is the correct answer. That's in degrees. You could also have it in radians. Yes, 60.45 or 60.5 is this degrees or radians, whichever you wish to keep. Okay, then question number 5 says integrate this. Now, typically this is a question in partial fractions, but I don't have two factors in the denominator. But what I still see is that if I open up the numerator, it becomes x squared plus x over x squared plus 4, which means that it is an improper fraction. So I know that it's going to break up into a plus bx plus c over x squared plus 4. Okay, so what I'm going to do is I'm going to first try to do partial fractions on this. For a, you take the highest power in the numerator and the highest power in the denominator with its coefficients and see that this breaks down to 1. So I have 1 plus bx plus c over x squared plus 4. Okay, so I get x squared plus 4 plus bx plus c to x squared plus x. Now I'm going to do a cover up method. Since I have no brackets, I can take any values of x. Let's take x equals to 0 and see that what value of an unknown if we are getting something. So c equals to -4. And then if I have x equals to 1, so this becomes 1 square plus 1, 1 square plus 4 plus b times 1 minus 4. So I get b as 1. So my partial fraction actually breaks down into 0 to 6, 1 plus x minus 4 over x squared plus 4. Okay, 1 can simply be integrated into x, that's fine. Now, for integrating x minus 4 over x squared plus 4, you've come across a situation like that in the previous past papers as well. So this in, includes a separation of the numerator. I can just separate the numerator and say that both of these can be divided by the common denominator that I have. Okay. Now, for the first, now what I can do is I can have integration signs for both. And say that I can recognize this with 2.5. So this becomes half ln x squared plus 4. And this one is tan inverse. Okay, this one is tan inverse. So this becomes 4 into half tan inverse of x over 2. That gives me 2 half ln x squared plus 4 and x here. Then I want to plug in values of, let me just check if I've done my workings correctly. Yes, they seem correct so far. 6 plus half ln um, 6 square plus 4 minus 2 tan inverse of 3. Okay, 6 over 2 is 3. That's the upper limit minus the lower limit. That gives me 6 plus half ln 40 minus 2 tan inverse of 3 minus half ln 4. So I think I can just deal with the ln's now. I can take a half common and say that this becomes ln 40 minus ln 4. So 6 minus, it doesn't say a simplified form, so I could exact value. Okay, so I need the exact value, so I'm going to say 6 minus 2 tan inverse of 3 plus half ln 40 over 4, which is 10. So that should be your final answer. Moving on, there's a third sketch. By sketching a suitable pair of graphs, show that the equation this has one root in the interval. Okay, so for the graph of 2 minus cos x, you could use your calculator and come up with the graph. I'm just going to try to do it directly, and I just need to show you up till pi over 2. So I'm just going to do that. I'm just going to stretch it a little and say that I'm going to pi itself just to make sure that the graph is more appropriate. Okay, so when I have, I know that cos x typically looks like this, so minus cos x will look like that. It's and it has a plus 2 as well. It's best to sort of use your calculator and come up with um, a solution, a table, so that you can sketch it properly. I'm just going to try to do it manually here. Okay. So the graph of cos x would look like this. A minus cos x would instead look like that. And a plus 2 would mean everything moves 2 units up. So it's going to start here. and go like that. Okay, so that's the graph of 2 minus cos x. Then for cot x, if you remember the graph, tan x looks like this. So cot x looks like that. So I'm just going to say that comes down from infinity and goes down. And you mention that there is one intersection point. Therefore, one root. Show by calculation that this root lies. So you've got to create an f of x for yourself. You say that this is cot x minus 2 plus cos x. I can write 1 over tan x just to make things easier for myself. Then what I do is first I calculate f of 0.6 on my calculator with my calculator in radians. This is giving me 0.287, then 0.8, minus 0.332. Okay, change of sign indicates root. Okay, use the iterative formula this to determine the root. So I'm going to start with x1 equals to 0.7 and do all of this on my calculator as we've demonstrated in several videos. Tan inverse, let's write 0.7, tan inverse of 1 over 2 minus cos of answer. Okay, so x2 comes out as, I want to give you each iteration correct to 4 decimal places, 0.6806 and 0.68, 0.6855, 0.69, 0.6843, 0.68, 0.6846, 0.68, and 0.6845. That's also 0.68. Okay, so the root is 0.68. I can say that correct to 2 decimal places. Okay, then it says by expressing 3 theta as 2 theta plus theta, prove the identity. Okay, so cos 2 theta plus theta. So I have cos 2 theta, cos theta, minus sine 2 theta, sine theta, 2 cos square theta minus 1 cos theta, minus 2 sine theta cos theta into sine theta. Two cos cube theta minus cos theta, minus 2 sine square theta cos theta. 2 cos cube theta minus cos theta, minus 2 1 minus cos square theta into cos theta. Yeah. Yeah, yeah, that is proving that identity. Hence, solve the equation this. So cos 3 theta can be written as 4 cos cube theta minus 3 cos theta. Then I have cos theta, and then there is another cos 2 theta. So 2 cos square theta minus 1 equals to cos square theta. So 4 cos cube theta minus 3 cos theta plus 2 cos cube theta minus cos theta equals to cos square theta. 6 cos cube theta and plus 2 and minus 1 will give me plus cos square theta. No, minus cos square. Oh, okay, there's no minus cos square theta minus 4 cos theta equals to 0. Okay, so then I know that I see cos theta common. So 6 cos square theta minus cos theta minus 4 equals to 0. So either cos theta equals to 0 or 6 cos square theta minus cos theta minus 4 equals to 0. Then A, B, C, you use the quadratic formula, you show me the working for the quadratic formula, and then you solve for cos theta. I'm getting cos theta equals to 0.904 and minus 0.737, 7374. Okay, when cos theta is 0, it's in all four quadrants, then so I write it in quadrant 1, I also write it in quadrant 2. When it's in just the positive ones, quadrant 1 and quadrant 4. Okay, why have I written in quadrant? It should technically be in all four, but I've just written it in the first two because the domain is 0 to 180. Okay, then this should be quadrant 2 and quadrant 3. Okay, so what's alpha cos inverse of 0 is 90 degrees. So quadrant 1 is 90, quadrant 2 is 180 minus 90. That's a repeated root. So that's also 90, that's also 90. Then alpha equals to cos inverse of 0.904. I hope that's the correct solution. I will know in a bit, I think. My calculator is set to radians. I'm getting 25.3. So quadrant 1 equals to theta equals to 25.3. That is indeed the correct answer. Cos inverse of 0.7374. I'm getting alpha as 42.5 and quadrant 2 will give me 180 minus 42.5. 137.5. Okay, so three answers are 90, 25.3 and 137.5. Okay, yeah, now those are the correct answers. Question number 8, it is given that this where a and b are real constants, show that 3a squared plus 4a. Okay, there are two things that I could do. I could cross multiply this, which seems like the easier thing to do, or I could rationalize this, but I think cross multiplying is easier. And then I'm going to compare real to real and imaginary to imaginary. So I get lambda 2a plus 4i minus ai minus 2i square. I've expanded the brackets. 2 plus 3ai equals to lambda times 2a plus 4i minus ai. Minus 2 into minus 1 will give me plus 2. So I get 2 plus 3ai, 2 lambda a plus 4 lambda I minus a lambda I plus 2 lambda. So let's compare the real parts to the real parts. So 2 equals to 2 lambda a plus 2 lambda. Okay, and imaginary to imaginary. So I get 3a equals to 4 lambda minus a lambda. Okay, here 2 feels common, so I'm going to remove that and I'm going to say that 1 equals to lambda a plus lambda. I want to remove lambda and prove to you something in A. So I'm going to say that there's a substitution involved, lambda equals to 1 over A plus 1. Using that substitution, I can say 1 over A plus 1 here and 1 over A plus 1 here. So I get 4 minus A over A plus 1. Cross multiplying gives me 3A square plus 3A equals to 4 minus A, and that solves. That is what I wanted to prove to you in the question. Hence, find the possible values of a and the corresponding value of lambda. So what I'm going to do is a quadratic. So I'm just going to apply the quadratic formula, 3a square plus 4a minus 4. So minus b plus minus root of b square minus 4ac over to a. I am going to put that on my calculator now and tell you if I have the correct answer. So I'm getting a as 2 over 3 and a as minus 2. So when a is 2 over 3, lambda is 1 over 1 plus 2 over 3, I think. 1 over a plus 1, yeah. And 1 over a plus 1. That gives me minus 1. And 1 divided by 5 over 3 will give me 3 over 5. Okay, so two values of a and two values of lambda. Question number 9, it says the diagram shows a curve this, to the maximum point this, where x equals to a. The shaded region between the curve and x-axis is denoted by r. Okay, so find the value of a. So it's just the maximum point. So in this case, I just have to differentiate. So dy by dx will be u equals to sine x, v equals to cos 2x, u dash is cos x, v dash is minus sine 2x into 2. So dy by dx is then u dash v plus v dash u, and then you put it equals to 0 and you try to solve. I think I have both sine and cos, so that would convert into tan. Tan x okay, and this point let me just check if I have things right. uh, 5 tan square x equals to 1. Yeah, okay, I have it right. And then you're going to say that tan square x equals to 1 over 5. I take a root. Either I get tan x equals to plus root 1 over 5 or tan x equals to minus root 1 over 5. Since this is in the first quadrant, I think, so I'm just going to take the positive one and say that I'm going to find out alpha, and that should be the value of x squared. Tan inverse of root 1 over 5. Radians. Radians. 0.421. It is correct to two decimal places of 42. Find the exact area of the shaded region R, giving your answer in simplified form. So I'm going to say that I have to integrate this sine x cos 2x. The limits are these values of x where the curve is 0. So I'm going to first have to find those and then integrate. Let's come to the integration in a bit. Let's first find out the limits. Sine x cos 2x equals to 0. So either sine x equals to 0 or cos 2x equals to 0. So when the sine x equals to 0, it's in all four quadrants. Then alpha is sine inverse of 0. So I get quadrant 1 as 0, quadrant 2 as 180 minus 0, which is pi minus 0. So that's pi. I don't need to go that far. I'm going to go and look at the other quadrant. So cos inverse of 0 is pi over 2, 90 degrees. So I'm going to say that quadrant 1 is 2x equals to pi over 2. So that gives me x equals to pi over 4. Quadrant 2 is 2x equals to pi minus pi over 2. That also gives me pi over 4. So that's the same. Quadrant 3 gives me 2x equals to pi plus pi over 2. So x equals to 3 pi over 2, which gives me 3 pi over 4. So I think I have my limits, which are pi over 4 and 3 pi over 4. Okay. Okay, then let's come to the integration part. I have two trigonometric equations, trigonometric expressions side by side. Typically, you're told that you can't use isolate there, but in this case, you can, and it's going to be a complicated integration if you go through that. Okay, let's try to think of other ways. We know that this is not integration by partial fractions. You can't apply partial fractions. There are two things being multiplied together, and that only happens when you have substitutions. But let's just try to simplify if we can and see that if we get something out of this that could help us solve this further. So I go with the identity that I have and I write down 2 cos square x minus 1. Okay, that gives me 2 cos square x sine x minus sine x, and I'm still about to integrate this. So I know that one of the parts can be integrated, so sine x can be integrated. What about this part? Now, since your syllabus has this idea about understanding integration as the reverse process of differentiation, what can be understood here is that when you have these expressions that are side by side, that are differentiation of one another. Okay, so cos sine x is basically the differential of cos x with the power. So the power came down and one power got reduced and so on. So what you have to do is sort of recreate that process. Or what you can say is that you can take a substitution yourself. Now, this concept is not there in the past papers. It is the first time that's showing up in the recent past papers. So you need to understand this. Typically, when you have these questions, there is certainly a part before this that sort of gives you the hint. In this particular question, they don't give you a hint. So what you have to do is you take this cos x that has a power as u and say that I'm going to integrate this separately and say that 2 cos square x sine x dx minus sine x dx. Okay, So in this case, what I get is 2u squared. Okay, what's the differential of u du over dx is minus sine x. So I'm going to say that dx should be du over minus sine x. So that cancels out. Minus 2 comes outside, and I'm supposed to integrate du squared du. This is when you see the differential of something right next to it, you take a substitution and you try to solve it. That's the best way of understanding this, although there are direct ways of doing this as well. You could have also sort of thought about, now when I integrate this, you'll see that it comes out as a cube, which means that this identity where you had a cube is sort of relevant. So there is a hint actually in the paper that you are supposed to use something, but it's in a completely different question. So just make sure that you understand what is going on and then try to solve this. Okay. Sin x integrates to minus cos x. And I have the limits pi over 4 to 3 pi over 4. I hope those limits are correct. Yeah. So minus 2 cos x cubed over 3. I replaced u again just to make sure that I have it correct. Let's quickly put that on our calculators and see if we get the correct answer. Cos pi over 4 cubed to minus 2 divided by 3. That's minus root 2 over 6. It's root 2 over 2. Cubed. So that's minus root 2 over 6 plus root 2 over 2. So minus 2 root 2 over 6 plus 2 root 2 over 2. So minus root 2 over 3 plus root 2. That gives you 2 root 2 over 3, I think. Yep, that is the correct answer. So unusual question in the past papers. Please make sure that you understand this properly before you move on. Okay, question number 10 says that the equations of the line L and M are given by this, where C is a positive constant. It is given that the angle L and M is 60 degrees. Find the value of C. Okay, so the angle has a formula that cos theta equals to B1 dot B2 over B1 mod into B2 mod. Okay, where B1 and B2 are the directional vectors, so 1, 1, 2, 2, 4 in C, 1 square plus 1 square plus 2 square minus 2 square plus 4 square plus C square. Cos of 60, cos of 60 is half, so minus 2 plus 4 plus 2C over root of 4 and 6, and 16 and 4 is 20, 20 plus C square. So that gives me 120 plus 6C square. And on the other hand, it gives me 4 plus 4C. Minus 4 plus 8 is plus 4. I square both sides. 120 plus 6C square equals to 16 plus 2 into 16 is 32C plus 16C square. So 10C square plus 32C, 16 minus 120 minus 104 equals to 0. Hope I am doing this correctly. Yep. Okay. Solving this on my calculator, you should show me the quadratic formula. So I'm getting c equals to 2 or c equals to minus 26 over 5. It says c is a positive constant, so this is discarded and I get just one answer out of this. Show that the length of the perpendicular from this to this is L is root 11. Okay, so this is a typical question. Where is line L? Line L is this. Let's copy the equation minus 321 plus lambda 112. Minus 321 plus lambda 112. Okay, so the general point is x, and it's going to have minus 3 plus lambda, 2 plus lambda, and 1 plus 2 lambda as its coordinates. There's a point P, let's call that P. It has the coordinates 6, minus 3, and 6. So what is going to happen is that Px is going to be perpendicular to this directional vector, which means that its dot product must be 0. Px is simply Ox minus Op, or you can just draw this line and say that it's the vector of this line. What is Ox? It's minus 3 plus lambda. What's Op? It's the coordinate minus 3 plus lambda, 2 plus lambda, plus 3, and 1 plus 2 lambda, minus 6. So I get lambda minus 9, lambda plus 5, 2 lambda minus 5, 1, 1, 2. Lambda minus 9 plus lambda plus 5 plus 4 lambda minus 10. 6 lambda minus 5 and minus 9 gives me minus 14. Just checking if I am getting the correct value for lambda. I think I've made a mistake somewhere. Let me check. Should come out as 12 rather than 14. Yep, I've made a mistake right at the start. This is 3 minus 2 and 1. So that changes a lot of things. Yep. So lambda equals to 2. So px is then 3 plus 2 minus 6 minus 2 plus 2 plus 3, 1 plus 4 minus 6. So I get 5 minus 6 minus 1, 5 minus 2, 3, and 5 minus 6 minus 1. So the modulus or the magnitude is 11. Okay. Okay, so the last question, the variables x and y satisfy the differential equation. The first thing is separation of variables. Notice that I have different sides of the expression. So what I'm going to do is I'm going to keep y squared plus y on this side and say that this becomes minus x squared dy by dx, just to handle the signs correctly. Then this becomes minus 1 over x squared dx equals to 1 over y squared plus y dy. I shuffled around and I've said that this should become minus x power minus 2 plus 1 divided by minus 1 plus c. Let's call that here. What this becomes is it breaks down into partial fractions. So I will have to do partial fractions here. I'm going to say that 1 over y um, 1 over y into y plus 1 breaks down into a over y plus b over y plus 1. So I get a into y plus 1 plus b into y 1 and equals to 1. First I take y equals to minus 1. So I get a 0 b into minus 1. It gives me b as minus 1. and 0. I get a as 1. So a over 1, 1 over y plus 1 over y minus 1 over y plus 1. Integrating that gives me ln y minus ln y plus 1. Okay, minus 1 over x plus c minus 1 over 1 plus c. I have x equals to 1 and y equals to 1. So I get c as 1 minus ln 2. Okay, I think that should be the correct c. Minus 1 over x plus 1 minus ln 2 equals to ln y minus ln y plus 1. Gathering all the ln's on one side, I get minus 1 over x plus 1 as ln y minus ln y plus 1 plus ln 2. So ln 2y over y plus 1 is to minus 1 over x plus 1. Okay, there were two negatives involved, so I think that's a plus then. Yeah, that's the mistake that I've made. Okay, that would be plus, that would be plus, that would be plus, that would be plus. Okay, so 1 over x plus 1, 2y over y plus 1, e power 1 over x plus 1. Let me check if I'm doing this correctly. Minus ln 2 1 over x. This seems to be a sign error which is coming from here, I think. This should be minus, this should be minus, this should be minus. Yep. Okay. 2y over y plus 1. Then I can cross multiply and say that y over 1 over x minus 1 plus e power 1 over x minus 1. I've cross multiplied. I'll now make y the subject. And that should be my final answer for y in terms of x. Okay. For the next part, it says state what happens to the value of y when x tends to infinity. So I'm going to paste this here and say that since I want the value in exact, I'm just going to show you. You can do this individually on a calculator and say that whenever you plug in infinity, this becomes e power minus 1. And this also becomes e power minus 1. Okay, in exact terms, 1 over infinity basically tends to 0, so 0 minus 1 gives me minus 1. Now I can simplify this further and say that this is 1 over e divided by 2 minus 1 over e. Okay, the answer on the marking scheme is this, therefore I'm just showing this to you. It's not necessary to do this. Your answer here is also perfectly fine. It's also in exact form. It's just not simplified enough, but I think you should get credit. Let me just check if the examiner is giving you credit for an alternate form or exact equivalent. Yes, it's giving you an exact equivalent, so that's your final answer. Thank you for watching. I'll be back with another video for A-level math. Thank you.